Today on Capechi's Corner, we are going to simplify radicals involving variables. Now, a radical expression is in the simplest form if the following conditions are true. The radicand, which is the number underneath the radical sign, has no perfect square factors other than 1. The radicand does not contain a fraction, and no radicals appear in the denominator of a fraction. Okay, so let's see how we do. It says simplify each radical expression. So 36, that's a perfect square, right? 6 times 6 is 36. Now today we're going to deal with some variables. So x to the 6th, let's do the square root of x to the 6th. That's equal to x to the 3rd. Now why is that? Because x to the 3rd times x to the 3rd is equal to x to the 6th. So as long as we have an even power attached to our variable, we're just going to divide that number by 2. So the square root of 36 is 6. X to the 6, so 6 divided by 2 gives me 3. So my final answer there is 6x to the 3rd. Okay, let's look at our next one. Now we know that 90 is not a perfect square. So the first thing I like to do is I like to break it up into 2 nice long radical signs. And this is going to be our perfect square radical sign. Everything that goes under there is going to be a perfect square. And this one's going to be what I call just our leftover. What is not a perfect square? Okay, so the first thing we're going to do is we're going to look at 90. So the highest perfect square that goes into 90 is 9. So I'm going to put my 9 in my first one. My leftover is going to be 10. Then I'm going to look at my x. I have x to the 5th. Now that's odd, so that's not a perfect square. So I have to go down 1. So from 5, I go down 1, which is 4. I put x to the 4th here. My leftover is x or right? Because x to the 4th times x is x to the 5th. Now my y exponent, that is positive, so that's fine where it is. That is a perfect square. So now in the end, the square root of 9 is 3. The square root of x to the 4th is x to the 2nd. The square root of y to the 8th, again, I'm going to take half of that, gives me y to the 4th. And then I have the square root of 10x. So that is my final answer right there. All right, looking at my next one again, I'm going to have one long radical and then another one. The first one's going to be my perfect square. So I'm looking at 98. Highest perfect square that goes in 98 is 49. So it's 49 and 2. X to the 4th is even. That's fine where it is. Y to the 2nd, again, fine in the first one. Z to the 3rd, I'm going to go down 1. Put Z to the 2nd. Put my leftover in the next one. Square root of 49 is 7. Half of x to the 4th, half of 4 is 2. So I have x to the 2nd. Half of 2 is 1. Same thing for the y. Y to the 1st. Z to the 1st times the square root of 2z. So I have 7 x to the 2nd, yz times the square root of 2z. Okay, let's take a look at the last one. That 5 out front, this is really 5 times that radical. So I'm just going to bring that 5 down so I don't forget about it. I need to multiply that at the end. So I'm going to have my 2 radical signs. 128, highest perfect square is 64. So it gives me 64 and 2. A to the 3rd, I'm going to bring that down to a to the 2nd times a. B to the 4th here. C to the 4th, and my leftover is going to be c there. Again, bring down my 5. Square root of 64 is 8. I get a to the 1st, b to the 2nd, c to the 2nd, times the square root of 2ac. Last thing I have to do is clean it up is take 5 times 8, which gives me 40. A, b to the 2nd, c to the 2nd, times the square root of 2ac. We're going to do some Keystone applications. So Keystone, this is for the Pennsylvania State Assessment Test. Since Pennsylvania is the Keystone State, that is why it's called Keystone applications. So it's asking you for solve for x. So we look at this. It can be a little bit overwhelming. So I need to know how to simplify radicals to do that, or I need to at least understand how square roots work. So there's 2 ways we can do this. We could just do a guess and check, or we can solve it algebraically. So we're going to try 2 different examples of this. So let's do it algebraically first. So I have 2 root 3 is equal the square root of 6x. Okay, I'm going to square both sides. That's how I get rid of my radical sign. I square both sides. And I have 2 root 3 times 2 root 3. That equals, when I have a square root and I square it, they counteract each other and it just gives me a power of 1. So I'm left with 6x. 2 times 2 gives me 4. Root 3 times root 3 is really the square root of 9, which is 3, right? Root 3 times root 3 is 3, is equal to 6x. So I have 12 is equal to 6x. Divide both sides by 6, and x is equal to 2. Okay, let's do our next example the same way. Do it algebraically. So again, I have 2 root 7 is equal to the square root of 14x. I'm trying to find out what x is, so I need to get rid of that radical sign. To get rid of the radical sign, I square it. That gives me what I need to the first power. So again, 2 root 7 squared is that multiplied twice equals 14x. So 2 times 2 is 4. Root 7 times root 7 is 7 is equal to 14x. So I have 28 is equal to 14x, so x is equal to 2. Okay, let me show you the guess and check method because again, it doesn't matter how you do as long as you get there. So the first thing I'm going to do is I'm going to take 2 root 3 and I'm going to figure out what that is in a decimal, approximately. So 2 root 3 is approximately, I'm going to round it, 3.46. Okay, so I'm trying to get something that the square root of 6x is going to give me 3.46. So let's try x is equal to 1. So that gives me 6 times 1, or the square root of 6. I take the square root of 6 and put it in my calculator. I get 2.45. So 2.45 compared to 3.46 is not high enough. So I need to go higher. Again, this is just guess and check. That's all I'm doing. I'm guessing, and if it doesn't work, I'm going to try it again once I check it. So I'm going to try x is equal to 2. I'm going to take 6 times 2, which gives me the square root of 12. Now, again, that can be simplified and with radicals, but I don't need to do that because I'm just going to put it in my calculator. And that gives me 3.46, which again is what I was looking for. So I'm okay. This method will let me know that x is equal to 2, which I already know by solving that algebraically. Okay, let's try the next one. Same idea. 2 root 7, that is equal to approximately 5.29. Okay, this time I'm going to try, that's what I'm looking for, 5.29. I'm going to try x is equal to 3. So I have the square root of 14 times 3, which is the square root of 42. I put that in my calculator, I get 6.48. That is too high. So I have to go lower. So I'm going to try x is equal to 2. So that gives me the square root of 14 times 2, which is 28, the square root of 28. I put that in my calculator and I get 5.29, which is what I was looking for. So I know x is equal to 2. So again, doesn't matter which way you do it, as long as you get to the right answer, and that will hopefully help you on your state testing. Okay, thanks so much for stopping by today. You have a great day.